Hey, welcome to QBRI. This is Quantum Biology Research Institute. My name's Dr. Kieran Johnson. I'm a quantum biologist, and I'm going to talk to you about the Hebeke singularity, or a helium Bose-Einstein condensate as a singularity before the start of time. Sit back, relax, and strap in your seatbelts because this is time travel. This is the Hebeke singularity, the geometry of the sphere of liquid helium before the beginning of time. Now, there are a number of special parameters associated with the Hebeke singularity that are associated with the formation of the universe as we know it. We have a diameter of c squared, or 8.98755 e to the plus 16 meters, which is twice the distance of the speed of light, hence the diameter being c squared and the radius being c. The electron-positron pairing within the Hebeke singularity means there's 16 fundamental particles, and they have a distance apart of 4e to the negative 14 meters. Each fundamental particle has a diameter of 4e to the negative 18 of a meter, 10,000 difference between that. After 13.8 billion years, you get an inward trajectory at the square root speed of the velocity of the outward direction. Okay, so the particles are getting closer and closer together, and they end up after 13.8 billion years at the Planck length distance of 1.6 e to the negative 35 of a meter, and that's a difference from the start to the end of 4e to the negative 22 meters. So we can understand what one side has moved inward, the inward direction, by the square root of 4e to the negative 22, which gives you 2e to the negative 11 meters. So this model gives a mirrored symmetry type approach to looking at the singularity before the beginning of time. If we look at the square root speed of the outward velocity as an inward velocity, and we multiply that with the length of time, we end up with 2.38503 e to the 22 meters traveled over that period of time. And there's a relationship between the inward journey and the outward journey, and that enables one to consider the formation of pi squared. And so that's really a velocity difference between the initial velocity and then the speed of light. And there's a decrease in the speed by 9.97 times, corresponding to the feature of pi. So pi squared equals around 9.97. It is a fundamental constant of nature due to the velocity difference between v and c, or the emission of alpha particles from the helium Bose-Einstein condensate, and the resulting decrease in the decay of the speed over time corresponding to the formation of pi. And that pi is associated with the inward trajectory from 4 different points, leading to 4 pi, and associated with epsilon naught and mu naught. So the model 1 over c squared equals mu naught e naught, or epsilon naught, provides the mirrored symmetry balance to the helium Bose-Einstein condensate with a diameter c squared. The beauty of the beauty of this model is that it provides an understanding of where the Planck length originates from, h, as a fundamental constant of nature. It identifies pi and pi squared as a way of the forming of positron-electron pairs through the decrease of the velocity of the initial alpha particle emission, which was 9.97 times faster than the speed of light. So the model has some very interesting parameters with respect to understanding the 1e to the negative 120 quantum field energy corresponding to the balance of mirrored symmetry between the inward trajectory down to 1.6 to the negative 35 of a meter and the mirrored symmetry outward trajectory of 6.25 to the 34 meters. And when we compare those two, we get a number of e to the 69 divided by the initial diameter of or the radius of the helium Bose-Einstein condensate of C. We end up with around 1.31 e to the 60. And so that is, in a sense, half the fundamental background radiation level of 1e to the negative 160. So there's an inverted symmetry associated with that. So we both have an outward and an inward trajectory from the initial beginning of the helium Bose-Einstein condensate in the Hebek supersymmetry inversion model. And this provides a way of understanding how we can perceive the start of the universe through a specific geometry where every action has an equal and opposite reaction. And by maintaining that balance point of 0, we can get a transformation happening where dark matter is generated on the inward trajectory and dark energy is generated on the outward trajectory. So we have a gravitational inward flow and an alpha particle dark energy based outward flow. And the inward flow is developing a singularity after 13.8 billion years that's separated by the Planck length, and that corresponds to the dark matter particle. So from the beginning, we can understand a new geometry of supersymmetry inversion that allows one to understand both the external and the internal relationship within the sphere and how the balance of opposites maintains stability of the 0 state, enabling transitions to occur and separation of 75% out, 25% in as the initial dark energy, dark matter combination that originated from the helium Bose-Einstein condensate. If we look further into the mirrored symmetry of the singularity, where 1 over c squared equals epsilon naught times mu naught, and the Hebek singularity has a diameter of c squared, and by rearranging Einstein's equation E equals mc squared to c squared equals E divided by m, the Hebek singularity provides a contextual framework for E divided by m being the right-hand rule of electromagnetism. So E and m are at 90 degrees to one another, the interaction between the electric field and the magnetic field. So in this rearranged equation of c squared equals E divided by m, we actually have the geometry of electromagnetism. M is magnetism, not mass, when it's inverted through this model. And what that suggests is that the s orbital structures contain photons of light as rings. And so the two ends of a piece of string have really been attached to one another to form the s orbital structure. This is a lens in effect where a photon of light has created a sphere. And what we have here is 3 different models. One is the s orbital models of hydrogen. That is looking at the Lyman, the Balmer, and the Paschen lines from the n equals 1, n equals 2, and n equals 3 layers of hydrogen. We have a model for a royal jelly protein isolated from Manuka honey that has been imaged by a nanosite microscope on the far right. That image is really atomic s orbitals, and it is a quantum property of single atom physics operating in the hexagon aromatic ring of a phenolic compound that's bound to the royal jelly proteins. The sun-like image is, in a sense, the singularity within the structure of an atom. So the nucleus itself with the event horizon of 1 over c squared, and the model on the left is plotting the rearrangement of Einstein's equation c squared equals e divided by m onto a mathematical cross where e plus and e minus are on the y-axis, m plus, m minus are on the x-axis, and c and negative c are coming out of the singularity, the point within the center of the atom. So in the case of hydrogen, where we have 3 quarks and an electron, the quarks and a proton are up, down, up, and we can understand that up in the SUSY inversion model is -1 and down is +1. So when we multiply -1 by 1 by -1, we end up with +1 for the proton, and with the electron being -1, +1 and -1 gives an overall 0 charge. So hydrogen is a stable mono atom in terms of its quark and its electron. And if you look at the calculations by adding the quarks, well, you've got 2 negative quarks plus 1 positive quark, and you've got a negative electron. So overall, hydrogen would have an overall charge of -2. But it really comes down to the geometry of the inverted model that allows the quantum entanglement between the electron and the quark. So they are both negatively charged, but with multiplication, the negative becomes the positive, and the inner quarks within the gluon field neutralize one another, and you have a quark that's negative that surrounds that as a sphere at 2e to the -9, where the electron and positron pair within the quark field are 4e to the -18. And the electron that's in the orbital layer is external to the hadron, which is the neutron or the proton that's housed within the nucleus of the atom. So when we're dealing with single atoms, we are dealing with a different rearrangement. We don't really have the same geometry as we do with diatomic systems like an oxygen with O2 or a hydrogen with an H2. In the SUSY inversion model, what we have to have is really the balance of opposites in order to maintain the 0 state of the atom to give it its stability. Dark matter is currently unknown. In the supersymmetry inversion model, it's postulated that because the Hebig singularity has an inversion system, or the trajectory inward toward the singularity at the square root speed of the alpha particle emission, so at a speed of 54,686 meters per second, we get a distance corresponding to a singularity of 1.6e to the -35 of a meter when we consider that inward trajectory after 13.8 billion years. And if you convert that into seconds, that's 4.3549 e to the +17 seconds multiplied by 54686, and that's giving us a number 2.38158 plus, or e to the plus 22, and we can see that we have this kind of inward flow of light from this Hebrew singularity starting point down to the Planck scale. And if you look at the numbers and do the calculations, you can see understanding of gravity is 6.67 e to the negative 11 meters cubed per kilogram to the negative 1, the seconds to the negative 2. The numbers that are kind of identified by this inward trajectory model correspond to numbers very similar to gravity. Okay, so we have a distance between the original distance apart of the particles in the Hebrew singularity of 4e to the negative 14 of a meter, and they're traveling down to 4e to the negative 1.6e to the negative 35 of a meter, and the difference between those two are 4e to the negative 22 of a meter. So the multiplication of the number obtained based by the speed at which that inward trajectory is occurring versus the number of seconds in the universe, multiplied by that kind of original starting position and the finished position, giving the 4e to the negative 22 of a meter, we end up having a number that is 6.24e to the negative 11. And that looks very, very similar to gravity as a number. So 93.43% of G is predicted by this inward trajectory at a velocity at the square root of the alpha particles being emitted as dark energy. So here we have a dark matter particle formation system that takes 4 particles out of the 16 in the original helium Bose-Einstein condensate. So 12 have gone out in the helium like alpha particle, and 4 go in. And that's the whole point of the supersymmetry inversion model. The rearrangement of quark charge calculations to give charge parity is that it gave the numbers that correlate to dark energy 75%, dark matter 25%, and that with 3:1 ratio at the beginning of time. And we can understand the decay processes that are occurring and how that correlates to what we know now as the composition of the universe, as 68% dark energy, 27% dark matter, and 5% matter. So dark energy and dark matter are generating matter in their decay processes. And we've kind of had a look and understood the flaws in the standard model of physics are based on the inability to see positrons within the neutron, the asymmetry caused by the measurement of atoms at the LHC. So the idea is really, well, we don't have to measure. We've got a model now that identifies what dark energy and dark matter are, understand the velocity of dark energy and dark matter based on a mirrored symmetry, or a balance of opposites, where the outward trajectory and inward trajectory have to be equal to one another, otherwise energy is going to be formed or created. And if we want to follow the first law of thermodynamics, where energy cannot be created nor destroyed but only transformed, here we have a transformation of the original Hebrew singularity into dark energy and dark matter. And from that perspective, we haven't created anything or lost anything. We've created a transformational process and understood that this potentially aligns with cosmology and also atomic physics, really just by looking at functional processes that maintain a zero state. Hi guys. I'd say that the supersymmetry inversion model gives some credibility for the observations that the gluon field, as the quarks come closer together in the nucleus, their strength lessens. And if we think about the inversion of Ka and the inversion of gravity to make the strong force, all of a sudden we've got a relationship of, well, 1 over gravity and 1 over the Coulomb's force. And if we look at how those two interact, we can create a relationship where the further apart the quarks are in the gluon field, then the stronger the force becomes, the gluon force. So it looks like it is a relationship between Coulomb's charge and the gravitational inversion through the singularity to create the strong force. So I've identified this relationship between the strong force and gravity. So that's how I've been able to integrate gravity down at the atomic singularity. And because of the supersymmetry inversion change in quark charge calculations based on positron-electron pairing and charge parity, we get to have a look at the relationship between the strong force and the charge and how that relates to the behavior observed with quark charges and the strong force and the strange behavior that the strong force has. So I've been able to predict strange strong force behavior as an inversion system. I see that the gravitational force and the strong force are one and the same through inversion, and I also envision that we're able to understand the quantum tunneling and entanglement process of 2 photons to create the 3 quarks and the electron, and the proton-electron pairing, or the 3 quarks and the positron and the neutron-positron pairing. And those 2 systems are actually really what's creating mass when we get asymmetry. So the asymmetry is actually being created from tunneling and entanglement, not from the beginning of time and cosmology and the baryonic asymmetry and missing antimatter issue. That is not where asymmetry comes into being. Asymmetry comes into being by taking 2 photons, a positron-electron pair as a photon, and through tunneling and entanglement, turning that into 3 quarks and an electron, or 3 quarks and the positron. So it is a different model. The supersymmetry inversion model is different, and it maintains charge parity with positron-electron pairs. It actually looks at charge on the surface, inside and outside surface of the electron and the positron, as a relationship to the velocity of alpha particle emission. So I can talk a little bit about that on a different page, but this really highlights that gravity and the strong force are one and the same, obtained through inversion, and that the strong force gluon field is actually surrounded by the strong force meson field. So the 2 quarks are inside the 3rd quark, and they get there through this tunneling and entanglement process. So there's an upfield shift where 2, or the electron and the positron, kind of come together, and if you multiply the electron and the positron, that's 4e to the negative 18 of a meter, you get 1.6 e to the negative 35 of a meter. And what that suggests is that from the four components down at the singularity, so the two positrons and the two electrons, we get a shift that allows one to go down to the singularity, or two to become that singularity and get encapsulated within the meson strong force. So there's suggestion that would give a relationship between the weak force and the meson. And the reason for that is that there's this entangled state that is created where the meson and the electron are the entangled state. And that's why there is this functional relationship in the handedness of the neutrino and antineutrino pairing with respect to which meson quark is connected either to a positron or an electron. And the neutron in the case of the positron, and the electron in the case of the proton. So in the supersymmetry inversion model, we have a different geometry. We don't have QECD or the quantum electrodynamics. That's not happening in as a form of an explanation. What we have is two quarks inside a meson quark, and we get an inversion of gravity and the strong force. So quite different with respect to what quantum mechanics is, but again, this supersymmetry inversion model allows gravity to be integrated down at the singularity, and that's something that quantum mechanics can't do. So I see this as quite useful as a way of describing the origin of the dark matter particle, because of the inverted trajectory from those four fundamental particles in the Hebbian isotropic universe at T0. And once we get down to that singularity after 13.8 billion years, then we can understand the tunneling and entanglement processes that are responsible for inverting gravity down to produce the strong force to hold the two gluon quarks together inside the meson quark. I shall hopefully provide some mathematical information in due course, but that's just really a highlighted summary of what I see as being responsible for the neutrino problem with the handedness with respect to the electron and the positron in the W Boson decay system. Thanks.